Hi, this is Tom Reardon, math teacher from Ohio. This video is one of several videos showing how to use the TI-Nspire dynamic geometry application to help students understand and discover geometric properties by investigation and exploration. Please pause as needed. This bit.ly website shows where you can get more information, including several activities with student sheets and teacher notes. Here we're going to focus on transformational geometry, especially dilations. So here is the dilations icon, and so we're going to say we want to dilate triangle ABC about point P with a scale factor of 2. So I'll press this icon, and it's a little bit big, so let me use the zoom feature here to see that a little bit better. You can see that it's not exact, it's the same shape but different size, and we can kind of pull this around, and as we work on the pre-image, we can see that the image responds accordingly. We can also pull point P and let that move around, and then also grab the pre-image, bring that in here. So a lot of things we can do here. One of the things I like to do is to just add the distance P to the vertices. So sometimes I do that, and you can see kind of the connections there. And as we move this around, kind of, those art teachers would like to talk about perspective here. So I'm going to go over to the tools here and click on the templates. We can talk about corresponding angles and sides, but let's look at perimeters and area because we're not going to be able to look at everything here. So right now it's telling you the perimeter of this triangle is that. So I think what I'm going to do is pull the point over here and pull this here so that we can see things better. I'm going to change the scale factor. Notice we have a whole bunch of scale factors here that we could use, positive and negative. Let's try 3. Okay, so I'm going to dilate triangle ABC with scale factor 3 about point P. So I'll go ahead and click on the dilation icon. Whoa, really big. So let's kind of pull that in a little bit. And you can see that the perimeters are much bigger. I'm going to go ahead and pull this, and maybe I can pull this so that I can see a relationship here. Ooh, there's some nice numbers here. So 36 and 108. Looks like that's 3 times 36 is 108. Maybe I can get some nicer numbers than that. So a lot of these are not nice numbers for sure. Maybe not. Those were my best numbers there. So here's a little bit better one. The perimeter of this is 24 and its image is 72, and 3 times 24 is 72. So it shouldn't surprise that the scale factor being 3 would let that happen. So I'm going to go on to the next button, and the next button takes those same triangles and computes their areas. And 3 times 24 is not 216. In fact, if you play around with this and divide these, it turns out it's 9 times that. 9 times 24 is 216. And then as I pull this around and see other numbers, like there's 30 and 270. Okay, also 9 times each other. $60 and 540, 9 times each other. So I can make that idea there, that hypothesis. And then what we do is we have the students, everybody do a different scale factor and see what the case is. And they come up with that the ratio of, well, let's actually see the next part here. The ratio of the perimeters is 3, which is the scale factor. And the ratios of the areas is 9, which is the scale factor squared. And it kind of points that out here. So all these things here to try to get them to come up with the conclusions and verify that. Again, if you pull this over here, you can see. And then when we go back to the perimeters, even though we have these nasty numbers, when we divide them, we're getting that 3. All right, going back here, let's look at a scale factor of -1. Some of you may have never done a scale factor before. So I'm going to rotate this with a scale factor of -1. Dilate rather. And you can see it's a similar figure, but it looks like it's been rotated 180 degrees. Again, we can go ahead and grab and see that. We can grab the whole figure, and we can grab even the point. And then a scale factor of, let's say, -1/2. Looks like it's half of what it was, but again, rotated 180 degrees. So you can go ahead and play with all of these things, and students can just discover. I know some of you have been saying, where's the grid, where are the coordinates, and so on. So let's go ahead and bring that in. So here I'm going to dilate this with a scale factor of 2, about point P. So I'll go ahead and dilate that. And you'll notice what happened to the coordinates, not surprising. Okay, if I need to zoom a little bit, I can do that. If I go to a scale factor of 3, again, not surprising. Scale factor of 1/2, again, not surprising. Okay. Let's turn on the slopes part of this one here. So it gives me the slopes of sides. And when I do a scale factor, let's try a scale factor of 1.5 this time. Okay, dilate this about point P with a scale factor of 1.5. You can see that the slopes of the corresponding sides are equal, which means that the lines would be parallel. And if I grab point P and move it, it seems to remain the same. Notice P could be one of the points on one of the vertices. It could be in the interior, be in the exterior. And again, I could bring in that distance P to the vertices. You can kind of see that. So a lot of playing you can do here, a lot of things you can discover. Other things we could talk about are, like I said, the sides are going to be affected by the scale factor, but the corresponding angles are equal. We did this one. A lot of investigation you can do with dilations. Please go to this bit.ly link and click on the link to get a 90-day free trial of the software so that you can not only do this activity, but all of these geometry activities on this website and over 1,000 pre-created Nspire activities at mathinspire.com. Please contact me with questions and enjoy.